welcome to lesson 89. This is called finding the square root. Now this is a pretty simple concept. If you know your multiplication, you just have to follow the rules as far as knowing what steps to do first. Now whenever I have a square with an area of 25, I know when I find the area, I'm multiplying two different sides. And all the sides on a square are the same length. So I'm really trying to find what is the length of all of the sides. If I have the area of 25 and I'm only multiplying two sides together, that means I'm multiplying 5 times 5 to equal 25 if that's the area in square units. So that means if I were to find the square root, given the area, I would find the square root, finding the length of one side, it would be 5. And all of the sides would actually be 5. So that is actually finding the square root, is just finding what times itself equals that number. So for example 1, it says the area of this square is 36 square centimeters. How long is each side? So each side is going to be the same length because it is a square. And I'm trying to find what times itself equals 36. Well, this is something that we have learned for quite some time since the very beginning of the school year. And I know it's 6 times 6 is 36. So answer would be 6. That would be finding the square root of each side, or the square root of 36, meaning each side is going to be 6 centimeters. And that would be my labeling because it is asking how long is each side. Area is in centimeters, so length will be in centimeters. So for example 2, now this is what the symbol of the square root looks like. So it kind of looks similar to a division sign, but it isn't. It has this extra part that comes out. So it's finding the square root of 100. So I'm finding what times itself equals 100. And that would be 10. So the square root of 100 is 10, and there is no labeling involved. The only time that you will need labeling is problems like these where it's giving you the area and you're trying to find the length of each side. That is finding the square root, but it also gives you measurements, and that's really what you're looking for. If you're given something simple as this, there's no labeling involved. The square root of 100 is simply 10. So example 3, we're comparing these problems. Now they look almost exactly alike, but when we solve it out step by step, we will actually see. When I have an addition problem or a subtraction problem or any kind of problem inside the square root with it going over completely, I need to solve it first. So 9 plus 16 would be 25. So I'm really trying to find here the square root of 25. Whereas here, I have the square root of 9. I'm solving it separately. Square root of 9, what times itself equals 9? That would be 3. And the square root of 16, what times itself equals 16? And that would be 4. Adding those together after, so I have 3 plus 4, or the square root of 25, which equals 5. 3 plus 4 is 7. So I'm comparing 7 over here and 5 over here. And I know that 7 is greater. So when you look at these problems, even though I have the same numbers, when the bar goes completely over, I need to solve it first. Whereas this, I'm finding the square root of 9 and the square root of 16 and then adding those two together. So the square root of 9 plus 16 is less than the square root of 9 plus the square root of 16. So for the practice set problems, you're going to find for C and D the square root of each of these numbers. And then letter E, you're going to compare the square root of 36 to 3 squared. In letter F, you need to find the square roots first, just like we did here. Find the square roots first and then subtract. Hopefully it'll be very simple. We'll go over your answers in class and do more practice together. Thank you very much.